going through this quickly, so you'll want to pause it so you can copy down. There's a lot of writing here. And then we'll get to 3 examples. Suggestions for verifying trig identities. I need to read that to you. You can do that. Again, don't forget to pause so that you can copy them down. The most important part of this is to have fun. Try to make a game out of it, make a puzzle out of it. You'll enjoy it a lot more. Otherwise, it's just hard work. First example, following our rules. We normally want to make the more complicated side simpler. Occasionally, though, it may look the other way. We certainly want to change sines and, anything that's not sine or cosine into sine and cosine if we can. And so in this first example, I see a cotangent here. I'm going to want to change that into sines and cosines. So on this side, it continues to remain cosine theta, and then sine theta times. And what's the cotangent? What's the reciprocal tangent, which is sine over cosine. So cotangent would be cosine theta over sine theta. Don't forget that sine theta here is really over 1. And so now it's probably clear to everybody that the sines cancel. And so cosine theta equals cosine theta. I'm sure right now you're thinking, boy, I hope they're all that easy. Unfortunately, they're not. The next example, and this is one where I'm kind of backtracking on one of the tips I said to make this complicated side into the simple side. I'm not. I'm actually going to take this side and transform it into the other side. And what gives it away to me, the reason I'm thinking about that is I look at this, and it almost reminds me of the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. And so I'm going to use the rule that says if I multiply by an expression equal to 1, then that's legal to do. And so I'm going to multiply both top and bottom here by sine theta minus cosine theta. And the other side, I'm not going to rewrite that all the way. It's just going to carry down. I'm going to transform the left side into the right side. And so on the bottom now, remember that's over 1. I'm just going to have sine theta minus cosine theta. And on the top, what I've turned into is I have the difference of 2 squares. And so we could FOIL that out if we wanted to, or you could just recognize that that's going to be sine squared theta minus cosine squared theta. The plus sine cosine and the minus sine cosine cancel, leaving us with sine squared minus cosine squared. And now I look up and I see on the other side I have a 2 sine squared theta. And so what I'm going to do is continue to use the Pythagorean identity, and I'm going to turn this cosine squared theta into 1 minus sine squared theta. And I got that from the identity, which I don't have on the board here. But the identity said sine squared theta plus cosine squared theta is equal to 1. And so if I subtract sine squared theta from both sides, I get cosine squared theta equal to 1 minus sine squared theta. And so where the cosine squared theta was, I'm going to replace it with 1 minus sine squared theta. And so if I distribute my minus sign, I get sine squared theta minus 1 plus sine squared theta. Remember, if I distribute this, that minus sine squared turns into a plus sine squared over sine theta minus cosine theta. and then I have a sine squared theta plus another sine squared theta gives me 2 sine squared thetas minus 1 over sine theta minus cosine theta. And I believe that's what we started with on the other side. 2 sine squared theta minus 1 over sine theta minus cosine theta. So we have just transformed the left side into matching up with the right side, proving that this original statement was in fact an identity. Okay. I'm sure you want to pause and slow down and stop and make sure that you understand what I was saying. I don't have time for that right now, so I'll leave that up to you. I'll move on to the final example. And in this one, I am actually going to work on the left side, which to me looks a little more complicated because A, it's got cosecant and cotangent, and B, it's got a square. So the first thing I'm going to do is FOIL this out or square it out, leaving it the way it is. And to do that, I would get cosecant squared x minus, and then remember the middle term is going to be 2 times the first times the second. So it'll be cosecant x cotangent x, and then plus, because it's squared, this last one's going to be a positive also, cotangent squared x. And again, I'm not going to copy this side down. Just know that we're going to move it down there and we're all done. We're going to make the left side match up with the right side. And then my next step, now I'm going to get rid of my cosecants, my cotangents. And so this becomes 1 over sine squared x minus 2 over 1 times 1 over sine x times cosine x over sine x plus cosine squared x over sine squared x. It looks kind of ugly there, but it does clean up because notice every denominator has a sine squared x in it. And so they already have a common denominator. And so on top I have 1 minus 2 cosine x plus cosine squared x. So now, if we look at this, and you will not spot this to begin with. This takes some practice and some getting used to. What we really have going on here is 1 plus, I'll use a y, 2y plus, I'm sorry, that's 1 minus 2y plus y squared. Change that back to a minus. And so this factors into something simple like 1 minus y and 1 minus y. Okay? It factors into that right there. And so that's what I want to do with this mess that's in the circle here. I'm going to take my 1 minus 2 cosine x plus cosine squared x. I'm going to factor it just like I did this. So this takes you back to chapter 9 of the Algebra 1 book, which you did a long time ago. And so we get 1 minus cosine x times 1 minus cosine x. Okay? And now, I know it's going to get worse before it gets better. But sine squared is the same, remember, as 1 minus cosine squared x. And again, that's a Pythagorean identity. We subtract cosine squared x from both sides, we get sine squared all by itself equal to 1 minus cosine squared. And this 1 minus cosine squared is the same as like having 1 minus y squared, which is the same as 1 minus y and 1 plus y. It factors into the difference of 2 squares. And so we get 1 minus cosine x times 1 minus cosine x over 1 minus cosine x times 1 plus cosine x. And so you can see here we have the same factor, and so they cancel, leaving us with 1 minus cosine x over 1 plus cosine x, which was exactly what we had started with on that side. Go back and look at the top. 1 minus cosine x over 1 plus cosine x. And that's what we ended up with. So now our left side matches up with our right side, proving that it is indeed an identity. And so this one was harder. I've tried to pick some that were a little harder on purpose. It included factoring, which you probably were never great at, but got pretty good at it when you were doing it. And now we have to factor with the trig functions, and that makes it a little more complicated. So there's 3 examples to help you get some ideas of how to do this. Do the best you can, and keep working on it, and don't give up. And again, treat it like a puzzle, and try to have fun with it, and it'll make it much easier for yourself. And this is a reminder of what your calendar looks like. So today we're working on 13 through 35 odds. Good luck.